Hey everybody, welcome back. Thanks for watching. So today we've got a cool little integral involving absolute values. In order to crack this thing open, we're going to need some tools. So first we're going to need, if a is less than c, which is less than b, and f of x is continuous on the closed interval ab, then we can decompose this in the following way. So the integral from a to b of f of x dx is exactly the integral from a to c of f of x dx plus the integral from c to b of f of x dx, so classic result. Next, we're going to need the formal definition of the absolute value. So the absolute value of x is equal to x, exactly for x's that are non-negative, and the absolute value of x is equal to minus x for x's that are negative. So with that said, let's go ahead and crack this thing open. Okay, let's see here. So we've got the integral from 0 to 2 of the absolute value of x minus 1 minus x. So the first thing we want to do is work with this using the formal definition of the absolute value. So let's note on the side here. Okay, so the absolute value of x minus 1 is equal to x minus 1 exactly for x's that are 1 or larger. And it's equal to, well, the negative of that, or 1 minus x, exactly for x's that are less than 1. That's just by the definition of the absolute value. Okay, so with that said, we should split this up because we've got a couple rules going on here. So we're going to have an integral from 0 to 1. And then plus an integral from 1 to 2. Okay, so next we use the definition of the absolute value. Okay, so for choices of x that are less than 1, this becomes this, right, just by our definition here. And then we said for choices of x that are at least 1, this becomes this. Okay, that's not so bad, right? So that's the absolute value of minus 1. And so that's 1. So yeah, not so worried about this. Now here, let's tidy this up. And it looks like we've got another absolute value to take care of. Okay, so again on the side, just by the definition of the absolute value, so the absolute value of 1 minus 2x, well, that's equal to 1 minus 2x. Now be careful here. That's exactly for x's that are 1/2 or smaller. And then this absolute value of 1 minus 2x is equal to 2x minus 1, exactly for x's that are larger than 1/2. Okay, so with that said, it looks like we've got to split this up now. So we've got the integral from 0 to 1/2 of the absolute value of 1 minus 2x dx, plus the integral from 1/2 to 1 of the absolute value of 1 minus 2x dx, plus from before the integral from 1 to 2 of 1 dx. Alright, so by carefully using our rule here, so for x's that are 1/2 or smaller, the absolute value here becomes this, and so I can rewrite that. So I've got the integral from 0 to 1/2 of, it looks like 1 minus 2x dx, plus, now for choices of x that are larger than 1/2, this absolute value becomes this, and we can use that right here. So there's 2x minus 1 dx, and then from before. Okay, so now we're going to compute. So you can see the hard part was just being careful, just carefully use the definition of the absolute value step by step by step by step, piece by piece by piece. Okay, so here we go. We should get the following. So here I'll have x minus x squared from 0 to 1/2 Here it looks like I'll have x squared minus x from 1/2 to 1. And here, well, we know that the integral from a to b of 1 dx is just b minus a, so I'll get 2 minus 1. Okay, so it looks like this will vanish at 0, so I really just need to evaluate here at 1/2. So it looks like a half minus a quarter. Plus here, if I plug in 1, that's going to give me 0, that'll vanish. And then I plug in a half, that gives me, it looks like a quarter minus a half. And that's just 1, of course. And so here it looks like I've got a half minus a quarter, which is a quarter. And then here, if I distribute the negative, I also have a half minus a quarter, so that's also a quarter. And then 1, so that's 1 plus a half. And so that's exactly 3/2, and that's the value of our integral.